This is the Math 2 lesson summary video for the lesson entitled Solving Right Triangles Using Trigonometric Relationships. The purpose of Lesson 10 in Unit 7 is to practice setting up and solving right triangles for unknown sides and unknown angles. We review our knowledge on the Pythagorean theorem as well as our trigonometric ratios to set up and solve equations. Recall that the sine of an angle is equal to the opposite side in a right triangle over the hypotenuse. The cosine of an angle is equal to the adjacent side in the right triangle over the hypotenuse, and the tangent of an angle is equal to the opposite side in the right triangle divided by the adjacent side. In the first part of Lesson 10, Solving Right Triangles Using Trigonometric Relationships, we were asked for each problem to make a drawing, write an equation, and then solve. And don't forget to include units of measure. So let's take a look at number 1. Carrie places a 10-foot ladder against a wall. If the ladder makes an angle of 65 degrees with the level ground, how far up the wall is the top of the ladder? So let's first draw our right triangle. Keep in mind that when the right triangle is drawn, in this case, the ladder will be leaning against the wall. So the ladder will be the length of the hypotenuse. It makes a 65-degree angle with the ground, and we want to figure out how far up the wall is the ladder. So the length we're trying to find is the side x. Based on where the reference angle is of 65 degrees, we need to figure out what sides we have and what side we need. Well, opposite the 65 degrees is the x, and we are given the hypotenuse. So if you recall, our trig function that uses opposite and hypotenuse is sine. So we would try to solve the sine of 65 degrees equals x over 10. So to get x by itself, we can cross multiply or multiply sine of 65 degrees times 10, which I've already done here in my graphing calculator. Just a reminder, please remember that when you're using sine, cosine, and tangent, you do need to be in degree mode. So approximately, it looks like x is about 9.06 feet. We went through all of these in class, but let's skip down to number 4. A hot air balloon is 100 feet straight above where it's planning to land. So let's just say the hot air balloon is up here. Sarah is driving to meet the balloon when it lands. We are told the angle of elevation to the balloon is 35 degrees. So recall from a previous lesson, the angle of elevation is from a horizontal line to a line of sight looking up. So this will be my 35-degree angle. And then they're asking how far away is Sarah from the place on the ground where the balloon will land. So we're looking for this value here of x. Based on where the reference angle is, we have the side opposite, and we're looking for the adjacent side. So opposite and adjacent, if you recall, is tangent. So we're going to try and solve the tangent of the reference angle of 35 degrees equals 100 over x, or divided by x. So to solve this, we need to get the x by itself, so let's multiply both sides by x. And then to get the x by itself, we will have to divide by tan of 35. So we will have to divide 100 by the tangent of 35. So let's go to our calculator and type in the tangent, 100, not 1,000, 100 divided by the tangent of 35 degrees. And that looks like it's approximately 143 feet. We'll round up on this one. So x is approximately 143 feet. So for all of these word problems, you want to definitely draw a right triangle, label what you know, figure out if you can use sine, cosine, and tangent, and then solve as we've done in prior lessons. As we moved along in this lesson, under number 2, we are asked for each right triangle to find any unknown side lengths and angle measures. So let's look at 8 first. If we look at this right triangle, we know how to find the missing angle because we know the sum of all the angles in a triangle is 180 degrees. Therefore, if I add 90 plus 42 degrees and subtract that from 180, I should get the remaining angle as 48 degrees. So now all of the angles are found in our triangle. Let's now try to find missing side lengths. I'm going to work from reference angle of 42 degrees, and I'm going to label opposite, adjacent, and hypotenuse. So opposite side from 42 degrees is the 8. Adjacent will be the little b. Hypotenuse is always opposite the right angle. So now let's try and find b first. So I'm going to write that will be opposite and adjacent. Opposite and adjacent is tangent. So the tangent of 42 degrees should be equal to 8 over x. And if we try to get x by itself, we would multiply both sides by x, and we'll get x equals 8 divided by the tangent of 42 degrees. And when we divide that in our calculator, 8 divided by the tangent of 42 degrees, we get approximately 8.9 feet. Or units, I apologize. There's no units actually here. So little b, whoops, let's make sure I'm writing, little b is approximately 8.9 feet. Now we have 2 ways to actually get little c. Because we now have 2 legs, we can actually use Pythagorean theorem. So let's use Pythagorean theorem on this one. It would be 8 squared plus 8.9 approximately squared, and that would equal little c squared. What I'm going to do in my calculator is I'm going to use the previous answer, and I'm going to square it, and then I'm going to add 8 squared. So I get approximately 142, and I'm going to take the square root of that answer to get my length of my hypotenuse, which is approximately, let's round to 12. So little c is approximately 12. And I apologize, I wrote feet there. We don't actually know the units on this one. So it would just be units in this case. Now let's just talk about in number 10, we're only given one angle. So let's talk about how we would find the measure of reference angle A. Recall that we have to use our inverse trig functions. So according to where that reference angle is, I'm given the opposite side and the adjacent. So I can actually do tangent inverse of 12 divided by 5. And recall on your calculator, you would have to do second tangent 12 divided by 5 in order to find that reference angle for A. And it looks like it's approximately 67.4 degrees. So angle A is approximately 67.4 degrees. So we did that for 8 through 11, filling in the missing, 8 through 12, I should say, filling in the missing angles and sides. So the last part of this lesson was part 3, where it said determine the values of the 2 remaining trig equations or ratios when given one trig ratio. So the best way to do this in number 13 is we're given the cosine of alpha equals 3/5. So what I would do is I would sketch that right triangle, and alpha is your reference angle. Recall that cosine is adjacent over hypotenuse. So the adjacent side to alpha is 3 units long, and the hypotenuse is 5. And we're asked to find the missing side in order to write our trig function. So if you look at this, this is what we call a Pythagorean triple, because 3 squared plus x squared equals 5 squared, and the x would be 4. So I know that this length, and that's just Pythagorean theorem, would be a length of 4. So now let's try and figure out our other trig functions. Let's do the sine. the sine of alpha is equal to the opposite side over the hypotenuse. And the last one is the tangent of alpha is equal to the opposite over the adjacent. So we found the other two trig ratios that relate to that information in 13. Let's look at one more, number 14. So I'm going to draw it down here. I'm going to label what I know. Tangent of theta equals opposite over adjacent. So now we need to find the hypotenuse. So let's do that math. 3 squared plus 8 squared equals c squared. That's 9 plus 64. And so that will be 73. So the square root of 73 is the length of the hypotenuse. All right, so let's write our other two trig functions. We're given the sine, so let's do the, we're given the tan, so let's do the sine. The sine of theta will be the opposite side from the reference angle divided by the hypotenuse. And the cosine of theta will be the adjacent side from the reference angle over or divided by the hypotenuse. Now, there is a radical in the denominator. We're okay to leave that right now, but we know that we will have to rationalize the denominator whenever we have a radical in the denominator, and we'll talk more about that when we get to Math 3. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.